Hello students! In this lesson, we will discuss about the different hydrocarbon representations. Specifically, we will discuss on how to write hydrocarbons in their molecular, graphical, condensed, and skeletal formula. Carbon being able to make at least 10 million known organic compounds, we found a way to graphically represent each one of them so that we will be able to identify each of these unique organic compounds. So, stay tuned till the end of this lesson as I'll be revealing the answers to our pretest. So, based on your prior knowledge, can you name these following hydrocarbons? For our first representation of our hydrocarbons, we have the molecular formula. So molecular formula is a chemical formula representation of a molecule or compound. So in this type of representation, we can see the specific kind of element and the number of atoms present in that specific compound. So I have here examples of our hydrocarbons. We have the heptane and the 1-butene. So as you can see on what we have on our examples, for the heptane, we have 7 carbons and 16 hydrogens. For the 1-butene, we have 4 carbons and 8 hydrogens. So as you can see, we have the specific type of element and the number of atoms present for each of that kind of element within the organic compound. For our next representation of our hydrocarbons, we have the so-called graphical formula. So graphical formula is just basically like a visual representation or a blueprint of our hydrocarbons to show us on how these atoms are connected to one another. So let's follow along with our previous example of the heptane. So we have here our molecular formula of C7H16. To make our graphical formula, we can follow along with two simple steps. First, we have to identify the number of carbon atoms present in that specific hydrocarbon. So in this case, we have 7 because it's an heptane. We have 7 carbon atoms. Next, we have to draw or connect these carbon atoms to one another in a horizontal or linear manner. So as you can see, we now have 7 carbon atoms connected. And then after that, since this is an alkane, a saturated hydrocarbon, we just simply have to attach all the hydrogen to the carbon atoms present. Now, take note of this crucial step. After you draw the graphical formula, you have to make sure that all of these carbon and hydrogen atoms present, when you count them one by one, the number is equal to the same number that we have for our molecular formula. So in this case, we have 7 carbons and we have 16 hydrogen. Take note that carbon atom can only have a maximum of 4 bonds shared with a carbon or a hydrogen or other element. So we should only have 4 lines connected to a carbon atom. Let's have another example, and in this case, we have our C4H8 or our 1-butene. So this time we have an unsaturated hydrocarbon, which means that it has a double bond because it's an alkene. So as you notice that we have a number before the name of the hydrocarbon, that is 1-butene. Take note that the 1 represents the location of the double bond within that carbon chain or the organic compound, which means that the double bond in this alkene is located in the first carbon connected to the second carbon. So let's show you the graphical formula for our 1-butene. So first step, we have to write all the 4 carbon atoms and connect them with each other. And in this case, take note, our double bond is located in the first carbon connected to the second carbon. Next, let's just fill up all these carbons with their respective hydrogen atoms. So as you can see, I've mentioned earlier that take note that carbon can only have a maximum of 4 bonds or basically 4 lines in a graphical formula. And the double bond is located in the first carbon connected to the second carbon. That's why we name it as 1-butene. And if you'll count them one by one, we have 4 carbons, and a total of 8 hydrogens. For our third graphical representation of our hydrocarbon, let's have our condensed formula. So from the name itself, condensed formula. So basically, it's just like having your graphical formula condensed or compressed to represent another graphical representation of our hydrocarbon. So I also have simple steps to follow along in the creation of this condensed formula. So let's have our same example of heptane. So for our C7H16, to get our condensed formula, we will be needing our graphical formula. So in this case, this is the graphical formula of our heptane. So to make it easy for us to track with the making of our condensed formula, this is what I do. This is my technique. I group these carbons with each of their hydrogen atoms attached to them. So for example, in the first carbon, we have 3 hydrogens. Then follow along with the second carbon, they have 2 hydrogens. Same with the third, fourth, fifth, and sixth carbon. And the last carbon, we have 3 hydrogens attached to the carbon atom. And then, after we have grouped them, we just simply compress them in making them into their molecular formula. But this is more like an expanded version of their molecular formula. So, in the case of our heptane, this is the condensed formula of our heptane. So, CH3, CH2, 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 and CH3. As you can see, it's just like we just compressed and then expanded the molecular formula to specify these individual carbon atoms and how many hydrogen atoms are connected to each carbon. Let's have another example. This is for our C4H8 or our 1-butene. So follow along with the steps. Let's have our graphical formula first, and then we group them by each of the carbon and hydrogen atoms connected to each other. So I just simply draw the circles. And then, after that, we just simply condense them into their molecular formula, but in its expanded version. So, always take note that since this is an unsaturated hydrocarbon, we have to specify the location of the double bonds, even in the condensed formula. So, as you can see, we have here the CH2, double bond to CH, CH2, and then CH3. And again, always take note that when you count these individual atoms, it should always match the number of carbon and hydrogen atoms in your molecular formula. And lastly, let's have our skeletal formula. So basically, from the name itself, skeletal formula provides us with a skeletal structure on how an organic compound or a hydrocarbon is connected to one another. So in order to make our skeletal formula, we just simply have to know the name of our hydrocarbon. So in this example, let's have our heptane, our C7H16. So to make our skeletal formula, we just simply have to draw zigzag lines. Yes, just having zigzag lines wherein each corner of that line represents a carbon atom. So in this case, for our heptane, this is the skeletal formula for heptane. So as you can see, we have 1, 2, 3, 4, 5, 6, and 7 corners. And that 7 corners represent 7 carbons. So this is the skeletal formula for our heptane with 7 carbons and 16 hydrogen. Let's have another example, and in this time, let's have our unsaturated hydrocarbon, our C4H8, our 1-butene. So since we know the name, we have the 1-butene. The 1 represents the location of the double bond. We just simply have to, again, draw zigzag lines to represent 4 carbon atoms in this skeletal formula for 1-butene. And the changes or the difference from the previous example is that we have to write down the double bond where it's located. And in this case, we have it located on the first carbon connected to the second carbon. That's why it's 1-butene. So let's count down. We have 1, 2, 3, and 4 carbon atoms represented for each corner of this zigzag line. And this is our hydrocarbon 1-butene. Alright, students, so that's just how easy it is to graphically represent our hydrocarbons in 4 different ways. So, thank you for staying till the end of this lesson. I'll now reveal the answer to our pretest. So, on what we have here, we have a graphical formula and a skeletal formula, and these are the name of these hydrocarbons. We have a 2-butyne since it has 4 carbons with a triple bond located on the second carbon, and the other item in the skeletal formula, that's a 1-heptene since it's an alkene with 7 carbon atoms. Thank you so much for listening to this lesson, and I hope you learned something in order to study your organic chemistry. So, once again, I have attached the PowerPoint presentation I've used in this discussion down in the description link below. Alright, so thank you, students, and I'll catch you in the next one.